Hello, students. Welcome back. Today's session is all about answering your geometry questions. So don't hesitate to ask anything you are curious about or need help with. Let's get started. The following figures represent the quarter of a circle. In figure 1, I want to get EC. Try to pause the video and have a go, and then check your solution against mine. So how can we get EC? They are here, this angle here is right. Okay, so we can construct a side here, and this side is radius. This is a radius. Pay attention. And the same length here, MA is a radius, so MA equals the same length, let's say MX here. So MX equals MA and also is equal to MC. All of them are radii in the circle. So how can we get MX? We can get MX by using Pythagoras. If we look at this triangle is right here. So we have 9, the two sides of the right angle, 9 and 12. So we can find mx by using Pythagoras. So mx squared equals 9 to the power of 2 plus 12 to the power of 2. It's 81 plus 144 equals 220, or here 81 plus 12, sorry. So 1 plus 2, it's 13. 1 plus 4, it's 5, sorry, and here 12 to 125. So mx is the square root of 225 equals 15 centimeters. So here the radius is 15 centimeters. So MA also is equal to 15. MA is 15, MX is 15, and also MC, because MC is radius, is equal to 15. So we can get EC by subtracting 15 minus 9 equals 6 centimeters. Here in the next example, we have a rectangle here drawn in this quarter of a circle, and the width here is 5, and this side is equal to 8, and I want to get the area of the rectangle. Remember, the area of the rectangle equals length times width, so we need to get EM. And how can we get EM? Because in the rectangle, each opposite sides are equal in length, so this side is equal to this side is equal to 5 centimeters. Okay, so here the radius is 13 centimeters. This side here is the radius is 13. The radius equals 13 centimeters. So we are going to construct here a radius from this point to the center of the circle, and this radius is equal to 13 centimeters. Now let's have a look at this right-angled triangle. We have 13 and 5, so we can get the length of EM. How can we get the length of EM? By using Pythagoras. So EM is the square root of 13 to the power of 2, the hypotenuse, the square of the hypotenuse, minus 5 to the power of 2. 169 minus 25 equals 144. So the length of this side is going to be 12. Now we can get the area of the rectangle. The area equals length times width. So the area of the rectangle equals 12 times 5 equals 60 centimeters squared. In this figure, AB is parallel to DC. They are two parallel sides. AB is parallel to DC. And X is the midpoint of AB. X is the midpoint of AB. Prove that Y is the midpoint of DC. Remember that the straight line passing through the center of the circle and bisect any chord pass through the center of the circle, and bisects any chord is perpendicular to this chord. So because X is the midpoint of AB, so MX directly is perpendicular to AB. So here we are going to write, since X is the midpoint of AB, then MX is perpendicular to AB. Here we have two parallel lines. The two parallel lines are BA and DC. And there is a line is perpendicular to one of them. You know that if we have two parallel lines and a third line is perpendicular to one of them, so this line here, L3, is perpendicular to the second line. So because AB is parallel to DC and YX is perpendicular to AB, so XY also is perpendicular to DC because they are two parallel lines. So here MY is perpendicular to DC. And because Y is the midpoint of DC, and you know that the straight line passing through the center of the circle and bisects any chord is perpendicular to this chord. So we are going to try it here, since MY is perpendicular to DC, so Y is the midpoint of DC. Let's go to the next example. Two concentric circles with center M. AB is a chord in the greater circle and intersected the smaller circle at C and D, as you see here. And ME is perpendicular to AB. Prove that AC equals VD. So let's talk about the smaller circle. Here in the smaller circle, ME is perpendicular to DC chord. So since ME in the smaller circle, ME is perpendicular to DC, then DE equals AC. This is number one. And if we went to the greater circle here, so just remove the smaller circle now and look at the greater circle only. You will find that ME is perpendicular to the chord AB. So in the greater circle, ME is perpendicular to AB. Then E is the midpoint of AB because this line is passing through the center of the circle and perpendicular to the chord AB. So this straight line bisects AB. So we will deduce that BE equals AE. That is number two. Subtract 1 from 2. When subtracting 1 from 2, so we will subtract DE minus, sorry, BE minus DE equals AE minus EC. You will end up with AC equals BD, because BE minus DE equals BD, so BD equals AC. That's it. AB is a chord of a circle M. AC ray bisects angle BAM and intersects circle M at C. If D is the midpoint of AB, prove that DM is perpendicular to CM. So I want to prove that DM here is perpendicular to CM. How can we prove that? Let's analyze it here. Here we have a straight line passing through the center of the circle and bisects this chord. Okay, so MD will be perpendicular to the chord AB. Why perpendicular to the chord AB? Because the straight line is passing through the center of the circle and bisects the chord AB. So MD is perpendicular to AB. Now look at this given here. AC bisects angle MAB. So angle 1 here is equal to angle 2. Let's write 1 and 2. Okay. If we looked at this triangle, here I'm going to color it in yellow. Focus on this triangle on. Here we have a radius. MA is radius and MC is radius. So this triangle is an isosceles triangle. So the size of angle 1 is the same size of angle 2 here. They are the same. Or let's write angle 3 because we have here angle 2. Once again, I said that MA is radius. MA equals MC equals R. So in triangle AMC, measure of angle 1 equals measure of angle 3. The triangle is an isosceles triangle. And we have a given. This given is AC bisects angle MAB. Then measure of angle 1 equals measure of angle 2. 1 equals 2 and at the same time 1 equals 3. So from this and this, we can deduce that measure of angle 2, then measure of angle 2 equals measure of angle 3. Let's focus on angle 2 and angle 3. It's angle 2 here and angle 3. Because angle 2 equals angle 3, and they are two alternate angles, and they are two alternate angles. So if they are two alternate angles and they are equal, so this side here is parallel to this side because they are equal. Angle 2 equals angle 3. Then AB is parallel to MC. Keep it now. And I said at the very beginning that D is the midpoint. Since D is the midpoint of AB, then MD is perpendicular to AB. From 1 and 2, we have two lines parallel. We have two parallel lines. They are parallel lines. And a third line, which is MD, is perpendicular to one of them. Let's focus on the two parallel lines again. I'm going to color them in red. They are two parallel lines. Here, this is a line and this is a line. They are parallel. I think it's obvious now. They are two parallel lines. And this line is perpendicular to one of them. This line here is perpendicular to AB. So if we have a line perpendicular to one of the two parallel lines, then this line here, MD, is perpendicular to the next line, is perpendicular to MC. And that's what I want to prove. You know, the tangent is perpendicular to the radius from the point of tangency. But in this example, I don't know whether if xy is a tangent or not. So I want to prove that xy is a tangent. To prove that xy is a tangent, we have to prove that this angle here is right, because the tangent is perpendicular to the radius. We know that mx is a radius. And I want to prove that xy is a tangent. So xy is going to be a tangent if this angle is right, the angle mxy. So here we have mx equals 5 centimeters. So this side here, the radius here, ml, is the same. It will be 5 centimeters. Let's have a look at this triangle, mxy. In this triangle, we have 13 here, 13 centimeters, and here it's 5, and here it's 12. So let's check this triangle being right or not by squaring the hypotenuse my to the power of 2. So find my to the power of 2, 13 to the power of 2 equals 169, and find mx to the power of 2 plus xy to the power of 2. 12 be 5 to the power of 2 plus 12 to the power of 2, 169. 25 plus 142, 169. We observe that the square of the longest side equals the sum of the other two squares of the triangle. So since my to the power of 2 equals mx to the power of 2 plus xy to the power of 2, then the triangle is right. Then measure of angle mxy equals 90 degrees. And if this angle is 90, and we have radius here, mx is a radius, then xy is a tangent to the circle. And the point x is the point of tangency. That's it. Here in this example, AB is a tangent to the circle, and the size of angle B is 30 degrees, and the length of the radius is 8. Find the length of AB and AC. The tangent is perpendicular to the radius from the point of tangency. So here, because we have a radius and BA is a tangent, so the size of this angle is 90. The size of this angle is 90. So right, since BA is a tangent to the circle M, then MA is perpendicular to BA. You know that the length of the side opposite to angle of size 30 in the right angle triangle is half length of the hypotenuse. Where is the hypotenuse? MB is the hypotenuse in this triangle, which is colored in red. So the length of this side here is 8. So the hypotenuse is 16 centimeters. So right, since in triangle MAB, measure of angle B equals 30, and measure of angle MAB equals 90, then MA equals half BM. So BM equals 16 centimeters. How can we get BA? It's very easy for you. We can get it by using Pythagoras. So BA equals the square root of directly the hypotenuse to the power of 2 minus this side to the power of 2. So BA equals the square root of 16 to the power of 2, 256, minus 8 to the power of 2 is 64. So BA equals the square root of 6 minus 4 is 2, and 15 minus 6 is 9, and here 1. So BA equals the square root of 192. The square root of 192 is 64 multiplied by 3. So the square root of 64 is 8. So it's 8 root 3. So BA equals 8 root 3. How can we get the length of AC? You know AC because this triangle is right, so we can get AC from multiplying 8 times 8 root 3 divided by 16. AC directly, it's the product of the two sides of the right angle, divided by the hypotenuse. So AC equals AM multiplied by AB divided by BM. So AC equals 8 times 8 root 3 divided by 16. We can simplify, divide by 8 1, divide by 8 2, divide by 2 1, divide by 2 4. So AC equals 4 root 3. That's it. Here in this example, AB is a chord of the great circle and touches the small circle at C. AB equals 8 centimeters and the radius length of the great circle is 5. Find the length of the radius of the small circle. So I want to get MC. That is the radius of the small circle. Let's have a look at the smaller circle. So forget the greater circle now and have a look at the small circle. MC here is the radius and AC is a tangent because this line touches the circle at C. So this angle is right. This angle here is right. So by using Pythagoras, before using Pythagoras, we will go to the greater circle again. So here, MC is perpendicular to AB. Do you know why? Because AB touches the circle, the smaller circle, at C. So MC is perpendicular to AB. Because MC is radius. And the radius is perpendicular to the tangent, and AB is a tangent. Let's go to the greater circle. In the greater circle, we have a perpendicular passing through the center of the circle, and the perpendicular passing through the center of the circle bisects any chord. So in the great circle, in the greater circle, we have MC perpendicular to AB. That leads to get a midpoint here. So C is the midpoint of AB. So AC equals BC. And AB equals 8 centimeters divided by 2 equals 4 centimeters. This side now is 4 centimeters. We can get MC by using Pythagoras. MC equals the square root of 5 to the power of 2 minus 4 to the power of 2, the square root of 9, which is 3 centimeters. That's it. M and N are two intersecting circles. Their GI are 3 centimeters and 5 centimeters. Then MN, you know what is MN? MN is the line of centers. And if the two circles were two concentric circles, so MN equals 0. If the two circles are touching, internally, then MN equals the difference between them equals 5 minus 3 equals 2 centimeters. And if the two circles are touching externally, then MN, the line of centers, equals the sum. 5 plus 3 equals 8 centimeters. But the two circles are two intersecting circles. So MN in this case is greater than difference and smaller than sum. So MN in this case is greater than 2 and less than 8. So MN belongs to the interval 2 and 8, opened interval 2 and 8. Two circles M and N with radii 8 centimeters and 5 centimeters are touching. Touching, it's not mentioned touching internally or externally, but we are going to deal with it as touching, both of them touching internally and touching externally. We have two kinds of touching circles, internally or externally. In touching internal circles, Mn, the line of centers, equals the difference between their radii, so 8 minus 5 equals 3 centimeters only. It's not an interval, it's a constant number, 3. And if they were touching externally, so Mn equals the sum of them, 8 plus 5 equals 13 centimeters. So here Mn belongs to the set. Don't write an interval because we have two constant values, 3 or 13. 3 if they were touching internally, and 13 if they were touching externally. So Mn belongs to the set 3 and 13. M and N are two circles with radii length 10 centimeters and 6 centimeters. AB is a common tangent. If the area of the triangle BMN is 24 centimeters squared, find the length of AB. You know, the common tangent is perpendicular to the radius. So here MA is a radius in the grid circle, so AB is perpendicular to MA. So right here, since AB is a common tangent, then MA is perpendicular to the radius. MA is perpendicular to the tangent AB. And the two circles are touching internally. The two circles are touching internally. So we can find the line of centers. The line of centers here in this case equals 10 R1 minus R2. So Mn here in this case, because they are touching internally, equals the difference. So R1 minus R2 equals MA minus AN equals 10 minus 6 equals 4 centimeters. So Mn equals 4 centimeters. The area of this triangle is 24. And the area is half times base times height. Where is the base? We consider Mn the base. And the height, from the highest point here of the triangle, we will go perpendicular to the extension of the base. So here it's the height. The height here is colored in red. And the base here is Mn. Once again, here it's the height. And here it's the base. And the area is 24. So right here, the area of the triangle is 24. And the area is half multiplied by base multiplied by 4 multiplied by height AB equals 24 divided by 2. So 2AB equals 24 divided by 2. So AB equals 12 centimeters. In this example, A and M are two intersecting circles at A and B. And C belongs to AB ray. D belongs to the circle N. And measure of angle MNB equals 125 as it's shown here. And measure of angle BCD equals 55 degrees. Prove that CD is a tangent. How can we prove that CD is a tangent? If we manage to prove that this angle is 90, so CD will be a tangent. Here in this example, we have two intersecting circles, and this code here is a common code. AB is a common code between the two circles. And MN is the line of centers. So the line of centers is perpendicular to the common code and bisects it. You know it? Once again, because MN is the line of centers. MN is the line of centers. And AB is a common code. Then MN is perpendicular to AB and bisects it. So this angle is right angle. Look at this shape. This shape is a quadrilateral. 1, 2, 3, 4 sides. This shape here is a quadrilateral. And the size of the sum of all side angles of the quadrilaterals equals 360. So since let's write here E, since A, E, or CE, CEND, CEND is a quadrilateral, then measure of angle CDN, the missing angle here, equal 360 minus the sum of the three angles minus 55 plus 125 plus 90 equals 90 degrees. So this angle is 90. We have a radius and we have angle of size 90. So the radius is perpendicular to the tangent. And if this angle was 90, so this side here or this ray here would be a tangent. So right here, since dn is a radius and measure of angle CDN equals 90, then directly DC is a tangent. AB and AC are two chords equal in length in the circle M. X is the midpoint of AB. Y is the midpoint of AC. And the measure of angle CAB is 70 degrees. Calculate the angle, the measure of the angle DMA, this angle. And prove that XD equals YA. So firstly, we have two chords equal in length. This chord here is equal in length AB equals AC. They are two equal chords in the fact. And because Y is the midpoint of AB, so MY is perpendicular to AC. Because Y is the midpoint of AC, so MY is perpendicular to AC. And because X is the midpoint of AB, so MX is perpendicular to AB. So here we have equal chords, and this MY in this case is a distance. Do you know why? My is the distance because the distance from a point to a line is the perpendicular line segment. So this is a distance. The distance from the center to AC. And because MX is perpendicular to AB, so MX is a distance. And you know that if we have two equal chords in the circle, then they are at equal distances from the center of the circle. They are equidistant from the center of the circle. So here, what we are going to try it. We are going to try it. We must show that since Y is the midpoint of AC, so MY is perpendicular to AC. I showed that MY is the distance from the center to the chord. And also write since X is the midpoint of AB, then MX is perpendicular to AB. I showed in the answer that MX is a distance. And since they are two equal chords, it's a given. Since AB equals AC, they are equal chords. And having equal chords in the circle leads to get two equal distances. So here directly you write, then MY, the distance here, is equal to MX. MY equals MX. They are equal distance. And here it's a radius. MY is a radius. and MD is a radius. So because they are two radii in the circle, so they are equal in length. So right here, you write here ME equals MD equals R. Okay, then subtract. Take MD here, take MY here, this MD which colored in yellow, take it from the radius. You are left with now YE, and take MX from the radius. You are left with XD. So because ME equals MD and MY equals MX, subtract, here we can write 1 and here's 2. Subtract 1 from 2. Subtract 1 from 2. You will end up with YE equals XD. You will end up with YE equals XD. And how can we get this angle? Because this shape is a quadrilateral. This shape here, which colored here in pink, is a quadrilateral, and we have angle of side 70, and this angle is 90. This angle is 90. So you will mention that this shape is a quadrilateral, and the sum of angles of the quadrilateral is 360. I explained something like that in the previous example. So here we have 70, here we have 90, and here we have 90. So we can get this angle. You will subtract 360 minus 90 plus 90 plus 70. It will be 110 degrees. That's it. Here in this example, measure of angle B equals measure of angle Z. Prove that CD equals XY. I want to prove that CD equals XY. So construct two constructions. Draw a perpendicular from the radius here to CD and draw another perpendicular from M to XY. And let's label it E. And here it's L. For instance, they are two perpendicular. So ME is a distance and ML is a distance. Okay. If we looked at these two circles, they are two concentric circles. And measure of angle B equals measure of angle Z. Measure of angle B equals measure of angle Z. So in the triangle ABZ, because we have to equal angles, so we have to equal sides. Then AB, the length of AB equals the length of AZ. The triangle is an isosceles triangle. So here they are equal. And they are two equal chords in the greater circle. So here AB equals AZ, and they are two chords in the greater circle, and they are equal. So if we have equal chords, that leads to get equal distances. So then ME equals ML. Do you know why? Because I said at the very beginning that ME, draw ME perpendicular to AB and draw ML perpendicular to AZ. So they are two distances from the center. Two distances from the center to AB and AZ. So ME is the distance from the center to the chord AB, and ML is the distance from the center to AZ. And because the two chords are equal, so the two distances are equal. So ME equals ML. Let's go to the smaller circle. In the smaller circle, we have ME perpendicular to CD and ML perpendicular to XY, and ME equals ML. They are equal distances. So if we have equal distances, in a circle, then that leads to get equal chords. Then CD equals XY. That's it. ABCD is a rectangle inscribed in a circle. Draw the code CE, where CE equals AD, as you see here. Prove that AE line segment equals BC. Prove that AE equals BC. Because this shape is a rectangle, so each two opposite sides are equal in length. So the length of AB equals the length of CD. And the length of CD is given equals to CE. So the three sides here are equal. The three sides AB equals CD because the shape is a rectangle, and DC equals CE, and that is a given. So you write here, since ABCD is a rectangle, then AB equals CD. And since CE equals CD, and this is a given, so we deduce that AB equals CE. AB is a chord in the circle, and also CE is a chord in the circle, and they are two equal chords. So having two equal chords leads to get two equal arcs. So the arc here, AB, is equal to the arc CE. Then measure of the arc AB equals measure of the arc CE. If we are going to add this arc to both sides, we are going to add this arc, which colored in black, BE, to both sides. So adding measure of the arc BE to both sides, then you will get arc AB plus arc BE. So you'll get the arc AE, measure of the arc AE. And also add this arc here to the arc CE. So add CE, add BE to CE. So when adding them, you will get the arc BC, measure of the arc BC. And having two equal arcs leads to get two equal chords. So the chord here opposite to AE is AE line segment, or AE chord. So AE chord equals, here we have the arc BC, and the chord opposite to it is BC, equals the chord BC, equals BC. That's it. Here in this example, in the opposite figure, AB is a diameter. AB is a diameter in the circle. And AC touches the circle at A. So AC is a tangent. So here AB is a diameter, and AC is a tangent. Okay. If AC equals 9 centimeters and MB equals 6 centimeters, find the length of BC and AD. First and foremost, you should know that the inscribed angle drawn in the semicircle is right. So this angle here is right. Do you know why? Because this angle is inscribed drawn in the semicircle. We have a diameter here. So this angle is right. Since AB is a diameter in the circle, then measure of angle ADB equals 90 degrees, and inscribe it in the semicircle. This angle here is right, and inscribed in the semicircle. And we have AC as a tangent. So since AC is a tangent, and you know the tangent is perpendicular to the radius, so AC is perpendicular to AB. AB is a diameter. So this angle also is right. So we can use Pythagoras, because we have in the triangle ABC, we have a right angle. So BC to the power of 2 equals, BC to the power of 2 equals 9 to the power of 2 plus, and this side here, this is 6, so this side is 12 AB. So it will be plus 9 to the power of 2 plus 12 to the power of 2. 81 plus 144 equals 225. Then BC is the square root of 225 equals 15 centimeters. So the length of BC here is 15 centimeters. Now we can get ED, and I explained something like that in a previous example. We can get ED because ED is a perpendicular drawn from the right angle. So BD equals 9 times 6 divided by 15. The product here of the two sides, 9 times 12, sorry here. 9 times AB, which is 12, divided by 15. We can simplify, divided by 3, 3, and divided by 3, 5. So here 3 times 12 is 36, divided by 5. It will be 7.2 centimeters. That's it. In the opposite figure, AB is a chord in the circle M, and MC perpendicular to AB. Prove that measure of angle AMC equals measure of angle ADB. ADB here. So construct a construction, draw MB. And this angle here is a central angle. This angle here is a central angle. And this angle here is an inscribed angle. And the inscribed angle is equal to the half of the central angle if they subtended by the same arc. And as you see here, they are subtended by the same arc. So measure of angle D equals half measure of angle AMB. Why is that? Inscribed and central. Subtended by the same arc AB. The common arc here is AB. The arc opposite to both of them. And if we looked at this triangle and this triangle, the triangle AMC and triangle BMC, they are two congruent triangles. Do you know why? Because AM equals MB. They are two radii in the circle. So they are equal. Okay. And also we have here right angle. So MC perpendicular to measure of angle MCA. The angle MCA equals the measure of angle MCB. Right and right. So this angle is right and this angle is right. And MC is a common side. MC is a common side. So the two triangles are congruent, which case RHS, the hypotenuse here and the hypotenuse here, the hypotenuse in the triangle, but radius in the circle. And we have R and R, and we have S common side here. So they are equal. They are two congruent triangles. And if they are two congruent triangles, so this angle here, measure of angle AMC equals the measure of angle BMC. So we can say measure of angle AMC equals half measure of angle AMB. Just to focus on this one here, measure of angle D half MB, and the measure of angle AMC half MB, let's call it 1 and 2. From 1 and 2, we deduce that measure of angle D, which we can say ADB, equals measure of angle AMC. Let's go to the next example. AB is a chord in the circle M, and CM is parallel to AB, as you see. And DC intersection AM equals E. Prove that BE is greater than AE. So let's have a look at this angle and this angle. This angle is central angle, and this angle is an inscribed angle. And they are subtended by this arc here. So the measure of this angle equals half of measure of angle M. So measure of angle B equals half measure of angle M. Do you know why? Because they are inscribed and central angle subtended by the same arc here, AC. So measure of angle B is less than measure of angle M, is equal to half of measure of angle M. And measure of angle M equals measure of angle A. Do you know why? Two alternate angles. So right here, since MC is parallel to AB, then measure of angle A equals measure of angle M. Two alternate angles. Okay. Then if we are comparing between angle B and A, that is 1 and that's 2. If you are comparing between angle B and angle A, from 1 and 2, measure of angle B equals half measure of angle A. What I want to say is that measure of angle A simply is greater than measure of angle B. And if we focus on this triangle, we have two angles and we are comparing between them. One of them is smaller than the other. So the greater angle is opposite to a longer side. So in this triangle, in triangle EAB, we have a smaller angle and we have a greater angle. So the side opposite to the greater angle is longer than the side opposite to the smaller angle. So which side is opposite to the greater angle here? This side is opposite to this angle. And which side is opposite to the smaller angle? This side here, AE. So we will say BE is greater than AE because we have two different angles. One of them is greater than the other. In the opposite figure, M is a circle, BC is a diameter, BC is a diameter, and measure of angle is 70, and DE is parallel to BC, DE is parallel to BC. Find the measure of the arc BD. So here we have two parallel chords. DE is parallel to BC. They are parallel. So the arcs included between them are equal in measure. So the arc, the measure of the arc BD equals measure of the arc CE. They are equal in measure, okay? Because they are included between two parallel chords. This angle here is an intersecting angle between two rays outside the circle. So this angle here, 70, is half the difference between what? Half the difference between the major arc here okay, the intersecting angle between two chords. So this angle here is half the difference between the major arc and the smaller arc. Half the difference between the major and the smaller arc. So this arc here is equal to 180 because this arc represents a semicircle. So measure of arc BC, let's write it. Measure of arc BC equals 180 degrees because it represents a semicircle. And the angle 70 is an intersecting angle outside the circle, is half the difference between the two arcs. So it's a half of BC minus DE. So 70 is half. BC is 180 minus this arc DE. Just to get rid of this 2 multiply by 2 both sides, I want to get rid of this 2. So multiply by 2 here and multiply by 2 here. So 2 times 70 is 140. Cancel 2 and 2. So 140 equals 180 minus the arc DE. So measure of the arc DE equals 40 degrees. That's 40. You know that the arc BC here is 180. Look at the circle wall. Try to understand. Don't panic yourself about writing. Just understand it. This arc is equal to this one, and this one is 40. So the three arcs here in the semicircle above BC equals 180. And we have two equal arcs. BD is equal to CE. So to get the measure of the arc BD, just it's 180 minus 40, then divided by 2. So 180 minus 40, 140 divided by 2. So this is going to be 70. And this is going to be 70. That's it. AB is a diameter in the circle M, and AB ray intersection CD ray equals E, and measure of angle AEC equals 30 degrees, and the measure of the arc AC is 80 degrees. Find the measure of the arc CD. You know this angle here is an intersecting angle outside the circle, is equal to half the difference between the included arcs, the major arc and the minor arc. So here, measure of this angle 30 equals half the difference between 80 minus dB. This 30 here, this angle 30 is half the difference between the included arcs, the major minus the minor. So multiply by 2 to get rid of this 2, both sides. So multiply here by 2, multiply here by 2. So 60 equals 80 minus BD. So BD directly equals 20 degrees. So here it's 20. You know AB is a diameter because AB is a diameter. Then measure of the arc AB equals 180. It represents a semicircle. We have here 80 and we have here 20. So we are able now to find this arc because the three arcs here equals 180. So this arc is going to be 80 plus 20, 100. 100 subtracted from 180 will be 80 degrees. So the measure of the arc DC equals 180 minus 80 plus 20. So 180 minus 100 equals 80 degrees. That's it. Here in this example, we have an intersecting angle inside the circle. And this angle 115 is not an ascribed angle and also is not central angle. So this angle, neither a central nor an ascribed angle. This angle is half the sum of the two opposite arcs. So this angle 115 equals half the sum, is half of the opposite arc here is 130 plus this arc here is BC. So multiply by 2 both sides to get rid of this 2. So 230 equals 130 plus BC. So BC equals 230 minus 130 equals 100. So the measure of the arc BC equals 100. Let's go to the next one. Here in this example, we have AB intersection CD equals E and EA equals ED. Prove that EB equals AC. Prove that EB equals AC. So how can we prove that EB equals AC? Look here. We have two equal sides here. So this angle is equal to this angle. Since AE equals DE. So measure of angle A equals measure of angle D. And this angle is an inscribed angle, and also this angle is an inscribed angle. Okay. So the measure of this arc here is equal to the measure of this arc here. They are two equal arcs. Do you know why? Because we have two inscribed angles are equal in size. So the measure of the arc BD equals the measure of the arc AC. The measure of the arc BD equals the measure of the arc AC. They are equal in size. And this angle here and this angle, both of them are equal. Do you know why? Because they are two inscribed angles subtended by equal arcs. So measure of angle B equals the measure of angle C, because the two arcs here are equal in size. So the measure of angle B equals the measure of angle C. And from that, EB equals AC. The triangle is an isosceles triangle. In this shape, I want to prove that measure of angle 1 equals the measure of angle 2. So we have here, let's say this is angle 1 here, and this is angle 2. They are equal in size. Do you know why? Two inscribed angles subtended by the same arc. Two inscribed angles subtended by the same arc. And this angle here is 3, and this angle here is 4. I want to prove that 1 equals 4 again. So I proved that 1 equals 2. They are two inscribed angles drawn on the same arc. So the size of angle 1 equals the size of angle 2. Two inscribed angles drawn on the same arc. And the measure of angle 2, so 1 equals 2. And measure of angle 2 equals the measure of angle 3. Two vertically opposite angles. Measure of angle 2 equals the measure of angle 3. Two vertically opposite angles. And measure of angle 3 equals the measure of angle 4. Do you know why? They are two inscribed angles drawn on the same arc in this circle. So measure of angle 3 equals measure of angle 4, inscribed angles drawn in the same arc. From that, we reach to a conclusion, which is 1 equals 2 equals 3 equals 4, and then 1 equals 4. That's it. In this example, ABCD is a quadrilateral inscribed in a circle M, and the measure of angle BCD equals 140. Find the measure of angle A. You know, this shape is a cyclic, but it's not mentioned in the given. ABCD is a cyclic because all vertices of this shape belong to a circle. So since ABCD is a cyclic, then, you know, in the cyclic quadrilateral, each two opposite angles are supplementary directly. So we can get angle A, because measure of angle A plus measure of angle C equals 180. So 180 minus 140 equals 40 degrees. So this angle is 40 degrees, because this shape is a cyclic. I want to get measure of angle B. So we can construct construction here, draw a BD. And this angle here is 90. Do you know why? This angle is 90. It's an inscribed angle drawn in the semicircle, because AB is a diameter. And the inscribed angle drawn in the semicircle, and if you found a diameter opposite to an inscribed angle, so this angle would be 90. So measure of angle ADB equals 90 degrees. But I want to get this angle here. This is a triangle. If we looked at this triangle is an isosceles triangle. So we have 140 to get this angle. Just subtract 180 minus 140 divided by 2. So you're right, since BC equals CD, this triangle is an isosceles triangle. Then measure of angle, this small angle, CDB, equals 180 minus 140 divided by 2. 40 divided by 2 is 20. So we have here 90 and we have here 20. So measure of all angle D equals 90 plus 20, 110 degrees. In this figure, BC is the diameter in the circle M, and ED is perpendicular to BC. Prove that the figure ABDE is a cyclic quadrilateral, and prove that measure of angle CD is half measure of arc AC. This angle here, CED, I want to prove that this angle is half measure of the arc AC. Here it's the arc AC. So firstly, I want to prove that this shape is a cycle. And we have here this angle is 90. You know, I said it many times today. This angle, because BC is a diameter, Then measure of angle BAC equals 90 degrees. You know why? Inscribe it in the semicircle. So this angle is 90. Inscribe it in the semicircle. Inscribe it in the semicircle. And this shape here is a cyclic because we have two opposite angles add up to 180. So since measure of angle A plus measure of angle A plus measure of angle EDB equals, both of them equals 180. So then ABDE is a cyclic. Why? Because these two angles add up to 180 and they are two opposite angles. Now let's go to the next one. I want to prove that this angle here is half of this arc. And it seems there is no kind of relation between them. But if we focus, you will find here this angle is an exterior angle. And this angle is opposite interior. So they are equal. Because I said the shape is a cyclic. So since this shape is a cyclic, then measure of angle CED. CED is the exterior angle. Equals opposite interior equals measure of angle B. The exterior angle equals the opposite interior. Opposite interior. Look at it again. This angle is exterior angle and this angle is opposite interior of this cyclic. So they are equal. And measure of angle B, because angle B is an inscribed angle and the inscribed angle is half the measure of the opposite arc. So measure of angle B is half measure of arc AC. Half measure of arc AC. So because this angle B is half AC, then measure of angle CED is also half measure of the arc AC. That's it. I hope you enjoyed this session and stay tuned for part 3. See you soon. Goodbye.